Alrighty, so from where we left off, we had started talking about piecewise functions. Okay, so let me just review what that is again. Essentially what you're doing is graphing two or more pictures, but only like parts of them. Okay, and so this over here tells you exactly what portion to graph. Okay, so for example, let's start with this easy one here. Okay. What is the picture for a constant? You guys remember from yesterday? Like y equals a number. What is that? Horizontal line. The horizontal line is going to be at -3. Okay? And this is telling me that it's only going to be there at x equals 4. So actually, instead of a line, we get a single point from this piece here. Okay? In other words, when x is 4, my output is -3, and that's it. So it's just a point there. Okay? Over here, it tells us what to do everywhere else besides 4. Okay? So here's a good way to do it. Do you guys remember slope and y-intercept? What's the y-intercept here?
2.
So 1, 2. Put a point there. What's the slope? -1/2. So that means go down 1, over 2, and we can repeat that, right? And we can get a line. But I know that I do not want to include this picture at x equals 4. It says do not graph this when x equals 4, right? So if I were to go down 2 and over 1 one more time, this is exactly where I would be when x equals 4. Does that make sense? So what I'm going to do is put an open circle there. All right? And everything else, if you just continue the slope pattern, is perfectly fine. And so your picture would look something like this. Okay? Are there any questions on the picture? Yes?
So why did you stop graphing after you got to 1?
Why did I stop graphing?
You didn't put dots in, you should put in circles.
I didn't put dots where? Here?
Circle.
Here?
Yeah.
Well, because it's not included. At this value where x equals 4, we do not want to include this value. That's what that means. That's why it's an open circle instead of a closed circle. Okay. All right, let's answer the questions now. Domain refers to all the x values, right? Bless you. So as you look at this picture from left, starting on the left, this picture does keep going to -infinity, right? So we're going to start there. And if we cruise along, are there any issues where there are no x values? Right here at 4. But there's an x value right there at 4. Does that make sense? So far there's actually no issues because we've hit every x value. From -infinity, it looks like maybe 4, we're skipping it, but right underneath it, there actually is an output there. So there's really not any issues with domain. And if you go right back, it does continue forever. Okay? Intercepts. Well, there's an intercept right here. What are the coordinates there? 0, 2. And it looks like there's an intercept there, but again, this is an open circle. So actually, we don't have an intercept for x. Does that make sense? This is the y-intercept, and there is no x-intercept. We already did the graph. Okay, now let's talk about the range. So the range is the y values. So if we start from the bottom and go up, does my graph go all the way down, first of all?
Oh, yeah.
It does eventually, yeah. Okay. So where is my first? Where's the first issue with domain? With range. What y values might we have a problem with? Well, it's not really 4. What's the y value here? 0, right? So nothing wrong here, nothing wrong there, but here there is a hole at y equals 0. And if I scan everywhere else along y equals 0, there is no other points there. Does that make sense? So it looks like we skip over 0. We hit every y value except for this 0 value. Does that make sense? So how do I say that? Well, we say from negative infinity to, where do we stop? 0. And then union. And then we do pick up immediately after 0. So we just use open parentheses there. Okay?
What's that like? Seinfeld getting union?
Yeah. This is the fancy symbol for union, which really just translates to the word or. In other words, our domain is from negative infinity to 0, or, range is from negative infinity to 0, or from 0 to infinity, not including 0, because there's a hole there. Yes?
Are you not putting brackets for units and open circle?
Exactly. Yes. If you go to my desk, you probably looked already.
Yeah.
Look on the desk to the right and see if you can find it.
Okay.
Let me know if you can. Okay. Last question here. Is f continuous? Continuous means, look, here's like the simple version of a continuous graph. Continuous, a good check would be that you can draw this entire picture without lifting up your pen or pencil. So can we draw everything on this picture without lifting up my pen or pencil?
No.
No, because I would have to lift up my pen and then fill in the circle, right, and then go back. Does that make sense? So this is not continuous.
If that point wasn't there, would it be?
If this point weren't there,
Yeah.
no, because we skip over that value. Yeah,
That's
exactly. Good question. And by the way, this is a jump discontinuity because we jump. Good way to remember it. We jump from 0. Instead, we want to have 4 for our answer. And then we jump right back to where we should be after that. Okay? Any questions on that? All right, let's see. Are we going to step it up to 3 now? 3 functions? Yes. All right. Do you guys want to try this one on your own, or do you want to go through it together? Okay. Let me try explaining it the other way, just so you have a couple of options and you can pick whatever one makes the most sense to you. Okay? So one way to do this is to just graph this thing. Sorry, you can't see what I'm doing. Graph y equals x plus 4 like you normally would. Okay? So what's the y-intercept for this? 1, 2, 3, 4. So there's a point. What's the slope here? 1. So up 1 over 1. And so my graph would look, if I continue that pattern, something like this. And I'm using pencil because part of this is going to get erased eventually. Okay? So here's the equation, y equals x plus 4. Correct? Now, what is this telling me? This is telling me that I really only want to graph this between x equals negative 6 and x equals 2. Does that make sense? So if you go to the negative 6 spot on the x-axis, the graph for it is right down here. Do you guys see that? So this is actually where I would start my graph, and I would not want anything prior to that, because this is telling me really we don't want anything before negative 6. We only want the line between negative 6, including negative 6. That's why it's closed. And then we would stop this when x equals 2. And so we go up to wherever the graph is at 2. erase everything after that. And now we need to make a decision. Should I have a closed or an open circle to end it?
Open.
Why open?
Because it doesn't have like the dash.
Yeah. Phil, did you have a question? I saw your hand.
No, I was gonna ask why. Like I didn't look. I didn't see that you had the closed circle at the bottom.
Oh, gotcha. Okay. All right. So does that make sense? Okay. And again, this is the alternate way of like doing these. It's like a little bit more work, but it helps if you see the entire picture and then just keep the part of it that you actually want, at least until you get really comfortable with these. Yes?
So why is it an open circle again?
Because this is less than 2, not equal to 2, so we don't want to actually include this x equals 2 value.
Oh,
Okay. -5. That's just what shape again?
Circle. All of it.
Horizontal line.
Sorry.
So again, I'm going to erase most of this, but here's what the picture looks like, right? According to what we talked about yesterday. What is this telling me here?
That it's only at 2.
Only at 2. So really, I just drew everything that I didn't want. The only thing I want is at x equals 2, a single point and nothing after that. Okay? I'm just trying to be consistent with how I explain things. I'm drawing the whole picture and then erasing the parts that I do not want. Once you guys get really comfortable with it, you could probably just only draw the part that you want as you start to really know these graphs. Okay? This is another line. We have -x plus 1. What's the y-intercept? 1. Slope is? So we can go up and over left 1 or down and right 1. And so my picture is going to look roughly something like this. And so on, right? But this is telling me to only graph this starting at 2 and greater. Does that make sense? So if I go to x equals 2, here's my starting value right underneath 2 here. And that's an open circle because it's not equal to 2. It's just greater than 2. Okay? And then I do want to include everything that's greater than 2. So that means anything to the right we want to keep. Anything to the left of that x equals 2 spot we don't want to keep. Okay? And so this would be our final, let me actually use my marker now so it's easier to see. This would be my final picture. Okay. Now we haven't talked about this yet, but do you guys remember the vertical line test to determine if something's a function or not?
Yes.
So if you take a vertical line, right, how many times should it intersect the picture? One time, right? So on this section, one time everywhere, right? So that's good. The only issue really would be right here. This vertical line looks like it hits these 3 points, but there's a reason for why we're drawing open circles. How many times does it actually hit anything?
Once.
Just this filled in one down here. And then certainly over here it passes the vertical line test, right? A good way to check to make sure that your piecewise graphs at least have a chance to be completely accurate is that they're always functions when you're done drawing these. Okay? So if for some reason you kept the wrong half and you had like a picture that looked like this where you had kind of an X over here, that would not pass the vertical line test. So that means you made a mistake somewhere. Does that make sense? Okay, so that's a good way to double check just to make sure you didn't do anything silly. All right, let's see if you can answer the questions now that we have the picture. So what's the domain? What are the intercepts? We did the graph already. What's the range? And is this continuous? So take a minute, answer those.
I think it's. So fun. Yeah, so they don't pull wires and then you shut Hi, Tyler. Hi, Tyler. Bye, Tyler.
Let's see how we're doing. What's the domain?
Is it bracket -6? And then
Very good.
Good job, Jared.
How many of you got that? Okay.
I get the bracket part.
Besides the bracket part. Okay, so a little more now. Why is it a bracket?
Because it's not infinity and it's a closer one.
Very good. Okay. Intercepts. Do we have an x-intercept?
Yeah.
What is it?
4. Or
-4?
-4.
So -4, 0. And is there a y-intercept?
It is
Positive.
0 or 0, 4. Good. Graph's already done. Range. What do we start the range with? I kind of gave it away with the parentheses. Negative infinity, right? Because this part of the graph goes down forever. Okay? And as we go up, are there any issues with y values? Potentially here, right? But
It's on the same.
you can go right over there and you've got a value there, so that's okay. Where else? Right here where I stop at 6, right? And since it's open, use the parentheses. Yes?
Wait, does it not matter that it's not like on -1?
This?
Yeah.
Well, this point right here is. We just didn't actually like put in all, there's an infinite amount of points, right?
Oh, yeah.
As long as you have a solid curve or a line there at that value, there's a point there.
Okay.
Does that make sense?
Yeah.
Okay.
Thank you.
Is this continuous?
No.
I mean, just from what we talked about, no, right? Okay. The greatest integer function, we'll deal with that later. Let's not worry about that right now. Okay. So we'll put a star, come back to this if need be.
Wait,
Let's.
one more time. How do you know if it's continuous?
If I can draw the entire picture
Oh,
without lifting your pencil up, in other words, it's like one piece,
Continuous.
one smooth piece. Does that make sense?
Yeah.
Okay. Okay. Let's let's do the word problem, because I feel like this will be easier than looking at this and finding the picture. But example 2. Just read the description real quick, so you kind of at least know kind of what's going on, and then we'll see if we can answer the questions. Example 2. Everybody read it? Okay, before we start talking the math for doing this, let's just think about it realistically, okay? If you understand what they're telling you, if I go to one fitness class, what am I paying for that month?
40.
Okay.
No, 55.
That's 40 because it's 240.
It says a monthly membership plan for 40, and I get 2 free classes included in that cost, right? Does that make sense?
Yeah.
So what if I go to 2 classes? How much am I paying?
40.
What if I go to 3? Now what happens?
55.
Now it goes up, and then we're paying 55. Does that make sense?
Yeah.
Well, mathematically, actually, let's just answer this realistically here. So how much was this going to be?
40.
This one was 55. What about this one?
Wait, do you buy the membership already and decide to not go? Or do you?
You know what? We're getting into some really tough stuff here. Let's make things a little bit easier to understand. Let's put a little equals sign there. Because, right, couldn't you join a gym theoretically and not go to a class?
Yeah.
So I think that might be a typo. Okay, so what should the cost be for 0 then?
40.
40. Okay. What about 6? How'd you get 100?
We did 15 times 4, and then added 40.
15 times 4.
Don't you get 2 free ones? So that means you pay for 4
Mm-hmm. You guys see what he's talking about? Okay. It's $40. How many fitness classes are you going to pay for that are not included? 4, because you get 2 for free. So 4 times 15 is $60. So you got to pay 60 plus the 40 from the monthly fee. Does that make sense? And actually, I'm glad that we did that first, just talking about it, because you know what? This is totally wrong, this function up here. Okay? Or maybe not. Something's not right here. What should this be? If x is greater than 2.
Why is it plus 25?
That's what I'm trying to...
It should be 15x plus 40.
Shouldn't it be 40?
Should it be 40? I don't think that's right either.
Well, I don't know where they
You're already paying
25.
40
for classes. So below.
add 15 for each.
But it's actually going to be... hold on, let's make this work. So, whoever typed this, I think, typed that incorrectly. Let's work backwards. So, the 15x makes sense. Because each additional class is $15 more. Does that make sense? Now, this number, let's figure it out. I don't know what it is. But it should give me 100 when x was 6, right? According to just talking about this problem and how much we're going to pay. So let's see if we can figure it out and explain whether or not that's 25. How should I solve for this? Plug x in. 15 times 6 is 90. So C should be 10. Does that make sense? So let's fix this in our notes. Okay, and now, now the math will make sense. Okay, so let's think about this. The way that you would do a piecewise function like this, just mathematically, so if I said, how much am I paying for 1.3 classes? I know that's not really realistic, but let's say that were possible. How much would I pay if I took 1.3 classes? 40, because 1.3 is between 0 and 2. Does that make sense? What if I took 1.99 classes? Still 40 bucks, right? What if I took 2.1 classes? Now it's going to be a little more than 40, right? According to this, anytime x is bigger than 2, I would use this rule. Does that make sense? So here's a couple more examples. Let's say I took 10 classes. Okay? We could figure it out, just by what Francisco said earlier and figure out how much extra to add to 40, right? But mathematically, does it make sense that I'm going to follow the second rule here because 10 is bigger than 2? Okay? So according to that, I would just do 15 times whatever my number of classes is plus 10. So 150 plus 10 is 160 bucks. Okay, does that make sense? How to interpret the pieces and which piece to use when? Okay. Last, and you know what? I don't think we're gonna take it easy today. We'll just do the 3-4 worksheet in class on Monday together. Okay. Let's look at example 1. Okay. And let's do B. Let's do B. We don't have to do them all, but can you guys look at this left piece and tell me what the slope is, what the y-intercept is, just by looking at the picture?
Slope is -1.
Okay, and what's the y-intercept?
-2.
So what would the equation be for that section over there?
Negative x minus 2.
Negative x minus 2. So for this piece, we have negative x minus 2. That's part of our rule. Does that make sense? Now let's go over here. The other piece has what y-intercept?
2.
2. What's the slope? So that would just be 1x plus 2. Does that make sense to you guys? Okay. Now obviously I'm not graphing this everywhere, and I'm not graphing x plus 2 everywhere, right? So over here, we're going to work backwards just like they tell us what parts to do. For what x values am I using this part of the graph, this left segment? For x is what? Well, where's the end of this graph? Let's start with that.
0.
At 0. Now, this is not an open circle, so we're going to say less than or equal to 0. So whenever x is less than or equal to 0, I should have this line. Does that make sense? What about x plus 2? Well, that's going to be the graph starting at 0, but not equal to, because there's an open circle there. Make sense? Take a minute, try C, and then that'll be the end for today. Okay. What's the equation for this line here?
Negative x.
Just negative x. Yeah. There's the y-intercept 0. You could have plus 0, but we don't need that, right? That doesn't change anything. What's the equation for this line?
Just 3.
Just 3. Everybody good with those two sections?
Yeah.
Okay. Now, what x values are we talking about for this line over here on the left? When
Everything greater than 3.
greater than 3 would be to the right of
Oh,
3.
it's less than.
Less than 3. Very good.
That's what.
And now what about this one?
X is greater.
X is also, well, not also, but it is greater than 3.
I read it wrong. I can't read it.
Yes.
Would you also have the point that
I'll try to
Oh, is there a point there?
Yeah. Wow.
Oh, wow. You didn't even see that. Yeah, why not? Let's make this even more interesting. Okay. Do you guys see what she's talking about?
Yeah.
This little dot. Let's pretend that that was bigger and it was really clear to see. Then we would just have an extra, let's sneak it in here. What's the value here at this point? What's the y value?
Oh.
1, and that's when x equals 3.
We can't see.
Thank you. Sorry. Does that make sense?
Yeah.
All right. That is good for today.